An example of being able to do a hypothesis test of one mean, where the standard deviation is unknown. In 2014, the average price of bananas was 51 cents per pound. In 2003, the following 15 sample prices in cents were obtained from local markets. Is there evidence to suggest the average price of retail bananas is greater than 51 cents per pound? We're going to test at the 5% significance level. We're going to start by defining the null hypothesis. Now we would assume that if this sample is completely random and there's no inflation, if there's nothing that would drive the cost of the bananas, then we would assume that the average price of the sample should be the same as the average price of the population. The alternative, if we read the problem, we have a greater than. So that means we're going to have x bar greater than mu for our alternative. At this point, variables. In this problem, the average in 2014 that is not associated with the sample size is 51 cents. Now, since everything is already in whole numbers, we're not going to convert to decimal. We'll just leave it as 51. To get x bar and s, what we're going to do is we're going to use the calculator. And we're going to use the one-var stat function in the calculator. So take this opportunity and enter all of the 15 sample prices into the matrix. If you hit stat and then you hit edit and you edit your list, enter these all into list 1. All right? And then from there, go ahead and select your one-var stat. Now I did this already, and hopefully you can verify this. I got that the sample mean x bar was 53, and that the sample standard deviation was 3.525. In the calculator, it's going to come up as s sub x. That's fine. S sub x is the same thing as s in our case. All right. Next thing we're going to do, we're going to find n. There are 15 sample prices. We know that alpha is given as 5%. All right, so that means we go up here, and again, to get alpha, we just look at the significance level as 5%. And then finally, a new variable that we need is t critical. Now, to find t critical, you're going to have an alpha level of 5% or 0.05, and the degrees of freedom, which is going to be n minus 1, 15 minus 1, is going to be 14. Right? So I have to look this up in my table. So go to your t distribution, and I'm going to do this as well. And if you go to your t distribution, if you go to, now remember we crossed out this top line, so this doesn't exist. Okay. Our alpha level is up top, so we go to 5% significance, and then we go to 14 degrees of freedom. Okay, so this is when, for t critical, this is when we have alpha is 5% and degrees of freedom is 14. So we get 1.761 for our t critical. So t critical is 1.761. Third step, we're going to go ahead and compute create the distribution. Okay, so remembering that this is a right tail test, so the right tail is going to be around here. Range of values for the t distribution, negative infinity to positive infinity. Remember, we got the t critical value, so right here is going to be 1.761. That's our critical value. The other thing to remember is that in the direct middle of the distribution is 0, and that's just more of a benchmark, so that when we plot the t value or the test value, we can go ahead and just plot it very nicely. Fourth step, compute the test value now. Okay, so this is our test value. To get the test value, our formula t is going to be equal to x bar minus mu over S over square root of n. We're going to put parentheses around everything. Remember that x bar was 53, mu was 51, and again, all I'm doing is I'm just going up top and I'm getting these from our data. We know that S is 3.525, and then finally n is 15. Okay, so try not to use that degrees of freedom, 14. Don't forget that n started out as 15. All right, now I'm going to write out the syntax in your calculator, which is the exact same syntax as the test we did before. In your calculator, you're going to take 53 minus 51, close parenthesis, divide, open parenthesis, 3.525, divide, parenthesis, 15, close parenthesis, close parenthesis. All right. Now this is if you don't have the symbolic manipulator. If you do have the symbolic manipulator, it's going to be a little bit different. Now I'm going to punch that into the calculator, so just give me a moment while I do that. And I end up with 2.197. Okay. So the last thing that we're going to do is we're going to go ahead and plot this. Okay, so we go up top here. 2.197 is bigger than 1.761. So our test value t, 2.197, that falls in the reject region. So we're going to end up rejecting the null hypothesis. Okay, so in this case, we are going to reject the null because the test value falls in the reject region. So we'll type this out, and just like we've done before, I'm just going to copy and paste what the question asked. So we'll go down here, we'll type that out. So we're going to say, since the test value falls in the reject region, we reject the null hypothesis. Hence, there is evidence to suggest, and I'm just going to paste the question, that the average retail price of bananas is greater than 51 cents per pound, and we should probably say in 2003, because that's when the samples were taken. So at this point, what I would suggest is go back through, make sure that all the steps are okay with you, and then try to work through the next problem. Now, in the next problem, on the guided notes, I did make one change. Okay, so the change that I made prior to working the problem is that instead of more than, I just changed it to is different than. So that way we have two different types of problems. So make that change, go through and try the problem, and then after you're done, then try to watch the video to see if you made any errors where you might have made those errors.